For being here today. My name is John Knapp. I'm the co-founder of Source 2050. We're a multi-vendor marketplace for high performance and passive house building products. We have 30 something vendors, several hundred products available. And we started this uh, uh, product workshop series in December. I think some of you attended that where we did a great profile of Timber HP and their new products. And we're going to be doing these twice a month going forward, featuring different brands that are on Source 2050, really digging in deep on to what the products offer, how they can be used in your high performance projects. And we're very excited today to have Michael Hooper here from Dorken Delta. Not only is he attending, but he is actually coming live from the Dorken base camp. Where is a training center and has lots of the materials and mock-ups all around him. So this is going to be a really kind of unique experience, better than just someone sitting in front of a presentation, a PowerPoint. We'll actually be looking at materials and answering all of your questions. Um, Kevin Brennan is here with Source 2050. He's going to be leading the kind of conversation with Michael and digging into the products that are available there. And Shannon Pendleton from Source is also here. She's going to be managing your questions. Drop them in the chat. As I mentioned, she'll be organizing and presenting them and making sure that we get answers to those questions. There may be some questions that are specific as we're looking at products. We'll try to get to those in real time if we can, while it's relevant, but we can always go back to a product at the end of the presentation if if we have to. So feel free to drop the question in whenever it comes up in the middle of the presentation or after. We'll make sure that we answer them all. So without further ado, I'm going to introduce Kevin, who's going to be kind of the MC for the hour. Kevin Brennan, take it away.
John, thank you very much. I'm Kevin Brennan. I'm the Director of Building Systems and Performance at Source 2050. Some of you may recognize me from such familiar programs as Passive House Accelerators Construction Tech on Tuesdays, or the Passive House Live sessions, where my co-host Shannon and good friend was also a part of that team. And one of the things that we pride ourselves on the accelerator was bringing the T's, the technical, the technique, and the technology too. And as somebody who's worked with Dorken in the past as an air barrier ABAA association trainer, it was always great to see Delta Dorken at trade shows, and they always supported training by sending products. So I got hands-on use to their product at trainings all the time, and it was good to see how intuitive the students took to the complete system and all their components. So without further ado, we have Michael here at the Delta Base Camp that is launched in this past year in Beamsville, Ontario. It's a great training center up slightly north, and we hope to have some workshops or see you guys at trade shows. But without ado, I'll introduce Michael. Michael Hooper is a dedicated professional in the building materials industry with a passion for helping clients bring projects to life. He has built a career specializing in architecture, residential, and commercial sales. He holds a master's of building science from Ryerson University and a degree in construction science and management from George Brown College. Thank you, Michael. Please take it over.
Thank you very much. So I am going to be running this as a PowerPoint presentation. I can stop and interrupt and use samples and stuff like that as I go, but we'll go with the PowerPoint for now, and depending on the question, I may switch over. So just share my screen here.
Great. Side note, just feel free to ask your questions in the chat, and Shannon will collate them and bring them up as we have time, and we'll bring them up at the appropriate time. But please feel free. This wants to be an interactive session, and we want to be able to answer any questions you might have, and then refer it back to maybe the mock-up or some product samples that we have on hand.
Perfect. Thanks, Kevin. All right. So first, a little bit about Dorken. Dorken's been around a very long time. It's been around since 1892. It was started by two brothers and has grown into a multinational organization. The main facility is in Herdecke, Germany. And then about 10 years ago, we opened an additional plant in Hagen, Germany, because if you look here, we just ran out of space.
Michael, I'm not seeing your screen. So
Oh, no. All right, let's see. What is it you're seeing here?
It's the regular view.
Oh, all right, let me try this again.
there you go.
There it is. Yep.
All right,
Double click to enter full screen mode. Excellent. Good.
perfect. So that's our facility in Herdecke. And of course, no more real estate available. And we opened up this is about 5 miles down the road in Hagen, Germany. We also have facilities in Izmit, Turkey. And of course, where I'm located, it's Dorken Systems North America in Beamsville, Ontario, which is part of the Niagara Peninsula. So we got a large facility here, probably in the neighborhood of 200,000 square feet of manufacturing and warehousing space. So we are a full building envelope manufacturer. We have products that run from foundation to roof. So that includes foundation, rainscreen, water resistive barriers, and air barriers. So first of all, I'd like to mention, because we are a German company, they take a much different approach towards building than we do in North America. Their idea of a old building is 500 to 1,000 years old. Our idea of an old building is 40 to 80 years old. So all the products that we manufacture are manufactured for the German market. It's expected to last the life of the building. So these products are certainly going to be a high performance solution in the North American market for sure. So starting with the bottom, and this is from the foundation and working our way up, this is what started us in North America. So there was a need for this product, and there was code changes in the early 90s that facilitated the switch from, say, a bituminous waterproofing or damp proofing product to a system that protects the foundation, not requiring that sort of application. So this is an extruded dimpled membrane that provides an air gap between the foundation and the soil itself. So water can work its way in a couple of ways. It can go in through a crack. It can work its way through the material, through the pores of the material over time. By creating an air gap between the soil and the foundation, you don't have that capillary reaction drawing that moisture into the concrete, which keeps your basement drier. One of the other advantages to using a dimpled membrane as opposed to a sheet or fluid applied product is concrete. Well, there's two types of concrete. There's concrete that's cracked or concrete that will crack. And that's just the nature of the product. It's very strong, but it does crack. The dimpled membrane bridges cracks. Whereas a damp proofing product, once it cracks, it might bridge up to a 64th of an inch. It's not going to bridge much more. You'll start to get water infiltration. This works by creating that air gap. Should water get behind that dimpled membrane, water, much like human nature, follows the path of least resistance. It's going to go straight down. It's not going to go horizontally into the building. The only thing that would force water horizontally is some sort of external pressure. So hydrostatic pressure, which you shouldn't have when you have a drain system like this, or some sort of negative pressure inside or outside. Like I said, because that air gap exists, water tends to go straight to the bottom of the foundation and drains its way out. This meets building codes in both Canada and the US as a damp proofing product and standalone product for keeping basements dry. Down to 14 feet. Anything beyond that, you typically have to change to a waterproofing system with a drainage composite. So the nice thing about this product is it can be done extremely quickly. 2 people can usually do, your average size house in a couple hours, compared to the time and mess involved with bituminous products or sheet membranes. Also, you can start backfilling immediately, so no need to dry or anything like that. Again, it settles, it covers cracks in concretes, and of course, it drains away. And one of the questions I get frequently is, do we stop the drainage at the footer or do we extend it out? And From a code perspective, you can stop it at the top of the footer. We always recommend kicking it out over the footer to the drainage. That way it provides a clear path for that water to follow. And you've paid for the material anyway. You'll usually have excess because it's never the exact height you need. Make sure you drain it out to the drainage tile. That said, if you need to cut it short for whatever reason and stop it at the foundation wall, that's perfectly acceptable from a code perspective. We are a systems manufacturer, not just a product manufacturer. So along with that dimpled membrane, we have all the accessory products to go with it. One of the unique things about the Delta MS membrane is how it affixes to the wall. Still uses fasteners, but fasteners create a point load in holding it against the wall. These orange discs actually lock into the dimples and distribute the load over the course of 5 dimples, and it drastically increases the amount of shear force that it can withstand from backfill. We also have the appropriate sealants, and we have various flashing strips to seal it at the top of the foundation. So the mold strip is the widest at 3 inches. We have a flashing strip is 1 1 3/4 inches, and then we also have a traditional fastening strip that some legacy contractors still like to use. 95% of projects now use the mold strip. It's the most effective. The mold strip is UV stable and can be left exposed to UV. The dimpled membrane, the brown membrane, is not. It must be covered by soil. So we talk about the walls, but one of the interesting aspects of the way water works is it wicks through this material. And even though the wall isn't in contact with wet soil anymore, the footing is. So there's really nothing traditionally that stops water from rising up through the footing into the wall and eventually saturating the wall. This product is used and it's embedded. This is the footing barrier here, the blue membrane down here. This is installed directly into the wet concrete as the footing is poured. You put your keyway directly into this membrane. You can cut holes in it for any reinforcing bars you need to put in, and it actually works as a capillary break between the footing and the wall. Sorry, that's my Canadian pronunciation coming out. Capillary reaction from the footing to the wall. So this will actually stop that water from rising, which keeps your wall dry, and of course your slab inside the building would have granule soil or dimple membrane under that as well. So your slab stays dry, your wall stays dry, your interior stays dry. When you're installing the dimpled membrane over insulation, it's harder to use traditional fasteners to go all the way back to the foundation wall. If you're using 2 inches of XPS or more, you can use these screw fasteners, and it simply uses a hex bit, and you screw it directly into the foam, and that holds the dimpled membrane in place. We also have these grip fasteners. They don't hold as much force because we don't know what substrate the grip fastener is going to be attached to, but it can certainly be used to hold the membrane in place temporarily until you get some additional fasteners in. Here's an example of an application. In this case, they did use a damp proofing as well as the dimpled membrane. There is never any harm in using a belt and suspenders approach. Our membrane is code approved to be a standalone product. So the dimpled membrane is very effective at holding moisture away from the foundation walls. However, it does require the water to percolate through that soil and down to the drainage on its own. If you're in a situation where you have a potentially high water table, or say you're at the bottom of the hill and a lot of water can come in, you need to move that water away from the foundation quickly, you want to switch from a dimpled membrane to a drainage composite. Now, this is used in conjunction with a waterproofing membrane. It's not a standalone product typically. There are some states where it can be, but for the most part, waterproofing membranes are used. This points the dimples in the opposite direction. So instead of the dimples pointing towards the foundation, creating that air gap, the dimples point out with a filter fabric on the outside. This allows the water to filter through into that drainage plane and then down to the drainage below. Our drainage composites, we have several. It manages this water, and we use a co-extruded product that's a combination of recycled and virgin materials. The reason why we use 40% virgin materials is the more you process polymers, the less strength they have. They become brittle. So in order to maintain the flexibility and tear resistance that we're after, we do combine a certain amount of virgin material. However, we try to incorporate as much recycled as possible. The geotextile we use on this particular product is a Typar, and it is heat bonded to the dimpled membrane, provides high water flow capacity, high compressive strength, and as I said, it's used with waterproofing. So again, much like the MS, it's a fast installation. Typically, 2 people can do a typical house in a couple hours. You can apply over installation or directly to the foundation, and it spans all the cracking and settling as any sheet membrane does. It can also be considered a protection board and is often used in commercial sense over insulation to provide protection for that foam before it gets backfilled. And of course, being a high density polyethylene, it doesn't decay. But like all drainage composites, it is susceptible to UV. It does need to be covered within a reasonable time frame. Typically, that's between 15 and 30 days, depending on your climate zone and the amount of UV. So moving above grade, this is a really unique product that came to market several years ago. And one of the problems that we have with a lot of construction is we get a lot of moisture being driven in from the exterior into the wall cavity when we use absorptive claddings. So your absorptive cladding can be fiber cement, wood, stucco. It can be manufactured stone. All these materials, mortars, they all absorb moisture. That in itself isn't a problem for the cladding itself. Those products are meant to be exposed to moisture. The problem is, after your rainfall, you get the sun coming out and you get very high vapor pressure when that sun hits it and starts drying out that moisture. So this product is actually a dimpled membrane with, you can see the drainage grooves in the front as well. So any moisture that's driven in is stopped by the vapor impermeable Delta Dry. If it condenses, it drains down to the bottom and out. If around the seams, any moisture gets through, the dimples provide an air gap between the exterior of the sheathing and the Delta Dry, and convective airflow will dry that cavity out. The wall cavity itself, any humidity generated within the building itself, and there's a lot of sources of moisture. It can be cooking, cleaning, showers, everything, exhalation. All these things generate moisture. It needs to go somewhere. It usually works its way out through the walls through diffusion. You need a place for that moisture to go. So with vapor permeable products, you have the permeability. From a physics perspective, permeability works in both directions. You have some products that may vary ever so slightly in the permeability in which direction, but for the most part, they're essentially the same. In using a vapor permeable membrane with a dimpled membrane like our Delta Dry, we in effect create a system that creates a one-way vapor barrier. So we stop the inward vapor drive from that high vapor pressure and wet cladding while still allowing the building to dry out from the interior. And this would take place instead of furring strips. So it's really not a large deal to transition from furring strips to something like the Delta Dry product. So we have 3 versions of the Delta Dry. We have the regular one here, which is great behind fiber cement and wood products. We also have our Delta Dry stucco and stone. So this was the second product that came out. And again, we heat bonded a filter fabric on here. And the idea here was, if you're putting on stucco and stone, you're putting a lot of your brown coat or your scratch coat, and it's filling those voids. By having the filter fabric there, it keeps those voids open and allow the drainage cavities to do what it's going to do. Following that, we came out with the Delta Dry and Lap. And this has taken over the lion's share of the Delta stucco and stone sales because it really is a innovative and cool product. So this takes all the properties of the Delta Dry, and we include a fiberglass lath with it. The nice thing about this is we have done all the necessary testing for loading. This outperforms expanded metal lath, but it also has the advantage of being a single step install. It's hot melt glued to the Delta Dry. So it's a single install process. You don't need to install first your Delta Dry, then your lath system. And because it's fiberglass, it can easily be cut with a utility knife or scissors. It follows the same fastening pattern as metal lath, and fiberglass doesn't rust. So with stucco systems, it looks beautiful for the first number of years, but as that stucco ages and cracks and moisture gets in, you get that rust and then you get the bleed out, and that just doesn't happen with the fiberglass. So there's a lot of advantages to it, and we've done all the loadings. The fiberglass actually outperforms the metal lath by about 20%. And and that's from a shear test. So and that's with 2-inch staples. If you use screws and washers, this can hold up to 60 pounds. It's more than enough for any adhered stone application, prescriptive adhered stone application. Anything beyond that needs to be an engineered solution anyway. So this product is used to really minimize the amount of moisture that's in the wall cavity, and it is code compliant and provides that ventilation and drainage. The key to making this work, though, is an air gap that needs to be maintained top and bottom of the wall. So to be considered a ventilated cavity, it has to have 3/8 of an inch air gap. We create that at the top and bottom. We fill this space with a bug screen so you don't get any insects getting behind. And all our details are available on site. We've got extensive details on how to put it all together. So this is an example of the bottom of a wall assembly. You can see the Delta Dry product, and that's the bug screen below. It's got a typical flashing in this case, and you can see the in this case, it's a metal lath with your first scratch coat there. So we only butt the ends here. We don't try to lock the dimples together. Polyethylene tends to be susceptible to expansion and contraction. We don't want those dimples locked. So we've used these in some of the most challenging climates on the planet. This is, I believe, the BC coast, right on the Pacific Ocean here. It's a very warm, humid climate. The higher the humidity, the more susceptible these building envelopes are to moisture damage. Which brings us to what goes behind the Delta Dry, and this is our new and improved Delta Vent SA product. And this is a sheet applied membrane, self-adhered, and we use a unique 3-layer spun bonded polypropylene a composite product. And we use a thermal polyurethane vapor permeable performance layer in between. This has been tested to AC 38. It's very effective, and it does have fairly high permeability. So dry cup is 30 perms, wet cup 50 perms. We have a unique feature that provides a self-adhered strip on the face of the membrane on one side, so that when you do lap your membrane, you have an adhesive to an adhesive bond. This is unique to our product. I think there might be one other manufacturer that does the same. But these membranes are made from what's called a low surface energy product, and it is not as easy to adhere to. So when you have the adhesive to adhesive bond, you're going to be sure that you maintain that airtight barrier. So the nice thing about these membranes, self-adhered membranes in general, is when you put mechanical fasteners through it, provided there's no pilot holes, they do self-gasket. They provide water retention. It keeps water out, and it doesn't allow air leakage. And these are tested to ASTM 2178, 2357, and in Canada, the CAN CS 741, 742. Being a polypropylene, it is Red List compliant. We do have declare labels, and we're also working on environmental product declarations, which we anticipate having by the end of the year. The accessories to go with it. So we have the multi-band tape. This is used for detailing as well as end laps. We have a amazing tape called the Delta Flex Band, and this is a butyl tape with a spun bonded fabric facer, and this tape will actually stretch and will it doesn't have memory. So when you stretch it into shape, it maintains that shape indefinitely. We use EPDM type prefabricated corners for speed and ease of installation. We also have various primers that we can use. We can use the Delta LVC adhesive. We also have our HF primer, which is a water-based primer. Some of the other accessories are the Delta flashing. This is a butyl-based flashing available in different widths. This is typically used for windowsills. You can also, or brick ledges. You can also do your windowsills in our Delta LFS, which is a silicone liquid flashing. Delta Tilax is another detailing sealant that you can use as well. You can use the LFS or Tilax. They're both great products. Tilax is made in Germany. The LFS is produced here in North America. And this is an example application of the air barrier. I should mention our air barrier recently changed. It used to have a gray facer. When we changed the performance layer in between, it increased the ability for it to resist UV degradation. So in climate zones 3 and above, this has been tested and can be used for applications with exposure times up to a year. There's no other product in the market that has that sort of exposure time, and it's entirely because we switched to a TPU performance layer in between. Everyone else still uses a polyethylene with a calcium carbonate for permeability. For climate zones 2, it's 270 days, and for climate zones 1, we can have exposures up to 180 days. So we also have the Delta Vent S, which is the mechanically attached version of the Delta Vent SA. It uses a slightly heavier spun bonded polypropylene on both sides of the performance layer. With mechanical fasteners, it is subjected to more mechanical abuse, positive, negative pressures. We don't want mechanical fatigue to happen, so we do reinforce it with a little bit more fabric. And it does have quite a high vapor permeability at about 120 perms. So having the trilaminate means it is very resistant to tear off. It doesn't tear easily. Much like your Tyveks that are a single layer, they tend to be a little more susceptible to tearing. So the whole idea here is we do develop the full system and all the compatibility is tested, adhesion. We know everything works together. Should you come into a situation where you need to tie into another manufacturer's products, please feel free to give me a call on our tech line. I'm happy to help to assist you with that. So again, with the S, we use the same accessory products, the multi-band, flex tape, fast corners, etc. This would be an example of our mechanically attached, and this is on I believe this is a passive house. So another unique product for us is the Delta Facade. And we have two versions of that, the Facade S and SA. So one's self-adhered, one's mechanically attached. So this product is made specifically for open jointed cladding. So this provides a black aesthetic that goes behind the cladding so that you can add depth to these panels. We use a spun bonded polyester the polyester has a much higher tensile strength. Because this is exposed to winds that cladding would typically protect it from, we want that higher tensile strength. The membranes are coated with a acrylic coating that provides the UV resistance. And this will allow for open joints as wide as 2 inches and up to 50% of the overall surface area. And there is no other membrane on the market that allows that level of exposure. It's an incredibly permeable product at 312 perms, which means it's not going to slow down the drying of your assembly at all. So it is very dimensionally stable. It doesn't stretch. That's the nature of the polyester fabric. And again, highly UV resistant. We've had applications. Our president has a motorcycle, and he actually uses the facade product as a tarp because he finds it's far more effective and lasts far longer than any tarp that he can buy at the hardware store. So it is fully watertight, and it's tested and passes AC 38. And of course, this works in NFPA 285 compliant assemblies. Remember, NFPA 285 is for the assembly, not for the individual product. You can't use it as a standalone. You use much of the same accessories. The big difference here is the Delta facade tape, which is really just cut rolls of the Delta facade itself. So it's still a polyester fabric. It can be used in strips to detail around, furring strips or Z-girts or anything that would typically sit in front of the Delta facade product. Here's an example of it being used. I believe this particular application is in Germany. We also have the self-adhered version of the product. It's essentially the same product. It just has a butyl hybrid adhesive applied, and this allows it to be applied directly to substrates. In colder climates, typically you have continuous insulation. If it's a fibrous insulation, you have to use mechanically attached. You won't get a good bond with any fibrous insulation, such as mineral fiber. However, if you want to use EPS, XPS, anything like that, this sticks perfectly well to that. I should mention the perms is significantly lower because the adhesive that's applied to these membranes, despite the membrane being the same, the adhesive does lower that permeance overall. And this still comes in at a quite high 50 perms. I believe I've covered all of these, and of course, it's building code compliant. So from a code perspective, you can use this on any wall assembly up to 40 feet and be compliant. Anything above that, you need to look at NFPA 285 compliance assemblies. And again, same accessories that go with it. Here's some examples of projects that we've installed it on. I believe that's in Denver. So when we get above grade or to the roof, we have an entangled mesh system. So this takes entangled mesh and we thermally bond it to our Delta vent product to create a single install process for your roof underlayment. And this is typically used underneath metal roofs, typically standing seam. And depending on the manufacturer of the roofing system, you can use it underneath metal shingles, composite roofing. Our biggest concern here is because we are creating an air gap, that you don't overdrive the fastener and compress it and cause oil canning of the, whatever roof goes over top. Typically, when you use your standing seam roof, it's the clips themselves that are compressed and not the roof. So that's why standing seam is a blanket yes. And any other type of metal roofing, it really depends on the roofing manufacturer. So this product is 120 perms. It comes in 3-inch wide rolls, and it uses a random oriented polypropylene mesh. It's a entangled mesh that's typical in the market. We've just bonded it to make it faster to install, and of course, in doing so, we have all the tests results as a because composite product. We typically sell this with the nails included. However, because of tariffs, we have now broken that out to be sold separately, just so that the tariffs apply only to the nails and not to the entire package of Delta Trella. So we're just trying to keep it as affordable as possible for everyone. So the advantage in using a product like this under metal roofing is metal roofing being impermeable doesn't allow the substrate, the sheathing underneath, to dry. This creates that air gap and convective airflow in order to dry any moisture that does get through to the lower deck. In doing so, it minimizes the corrosion of the metal roof panels, as well as the fasteners that are used for the sheathing itself. Excuse me. One of the biggest knock-on effects of this particular product is how much it attenuates noise inside buildings. It can reduce the noise of a metal roof by as much as 15 decibels. And considering noise is rated logarithmically, this is 5 times quieter than metal roof on a wooden deck alone. So in doing so, it keeps the metal cooler, it reduces the expansion contraction of the metal roof, but also allows for that movement to happen. And that ventilation space is sufficient to allow any drying. And of course, it can be installed both vertically or horizontally. Probably the one of the most complex buildings ever constructed. This has Delta Trella underneath it. And of course, you can see there are thousands and thousands of metal panels, and they're all secured through the Delta Trella on this particular project. And this is just an example of how it all goes together, your typical drip edge. You still need ice and water shield in most climate zones. This would be applied over top to provide the air gap, and then you just continue up and you detail it around any pipe penetrations. So you'll see here, the heat bonded mesh, you can actually peel away from the membrane without damaging the membrane. It's been designed to have just enough heat to get that good bond, but not so much that you can't unbond it. And this allows you a smooth surface to apply any sealants that are required to go around any penetrations or any laps. You'll see here we use the Delta Flex Band tape. No sealants required. You can use just the tape. And this would be your aesthetic drip edge for your metal roofing. You have your appropriate ridge vent at the top. And you're done. So before I get into Delta FL, the Delta MS can also be used under the floor slab in basements. So it can be used to maintain that airspace. And it also provides a vapor barrier underneath the slab so that that slab doesn't get damp. It provides an air gap. If you tie it into a radon vent, this will work as a radon barrier as well. Now, if we're dealing with retrofit situations or after the fact, we have our Delta FL product, and this is used on top of basement floor slabs. This provides a vapor barrier and an air gap, and this keeps your floor warmer, provides a good substrate for your flooring, and prevents any of that moisture from coming up. So it's important to note that we use 100% virgin plastic for this particular application. And the reason why we do so is odors. When you use recycled plastic, you don't necessarily have a say as to what that source of the plastic is. It could have residue on it from whatever the previous use was, and that smell can actually come up through your flooring. We don't want that. So in this case, we do use a 100% virgin plastic in order to create this product. So in doing so, you don't get that dampness rising up. You can use laminate flooring on top of it. You can use laminate vinyl tile or strip. And it's easy enough that it can be done by a DIYer. So, as I mentioned previously, typically there's no vapor barrier underneath the concrete slab. Sometimes when vapor barriers are put in, you get contractors poking it full of holes so that the concrete dries faster. Of course, that's not good from a vapor perspective, and it's not good for concrete either. We actually want the moisture in it. We want concrete to hydrate, not to dry. It prevents or reduces the amount of cracks that happen in concrete. So, so this coupled with the Delta footer and the Delta MS keeps a very, very dry basement. So I believe that covers just about everything from a building envelope, from under slab, foundation, walls, roof. So some more information on this. The way it's designed, it doesn't provide waviness. It is important to note, though, that not all floors are completely smooth. And if you do get a gap between the dimpled membrane and the concrete, you can get a little bit of a clicking noise. So you may want to put a filter fabric down to provide something to stop that clicking noise. If your concrete is smooth, you won't have that issue.
Great. Thank you, Michael. Great presentation. I appreciate your diligence and sharing all the details. I know from my high level perspective, it's great to see a company embrace from slab to roof to under slab to wall air barrier, vapor barrier solutions that are delivered as a system. I personally love to see flashing options. I mean, you guys have liquid flashing inside the rough opening. You have the regular peel and stick options inside the traditional rough openings that you have. You sent me some samples. I can't really show them here, but they are great products. They're easy to use. A little bit of training gets them installed pretty well. Let's kick it off to the first question. All right, Shannon, let me look at the run of show here. I think the first question was a retrofit question, which was it was from Brent, and Brent wanted to know, can this be used as a basement retrofit as an interior drainage plane to drainage tile? So I think he's saying, I think we just covered it a little bit, but.
Good question, one I get quite frequently. It absolutely can. So typically this is where you're trenching around the basement floor and putting an interior weeper in. You would put this on the wall, put your French drain or weeping tile in and re-pour the concrete over top. You absolutely can use it on the interior weeper. The one caveat that I do recommend when you do so is you are creating a direct path from under the slab into your living space. So we don't know where radon is. What I would recommend is you tape all the seams. You don't need to tape MS when it's on the exterior, but when it's on the interior, we want to make sure that you're not introducing soil gases to your interior. So please, please, please tape all your seams. But absolutely, you can use it on the interior.
Great. Thank you. What else do we have? Second question is from an existing source customer. All right. Please explain when to use MS mold strip versus MS flash. Are they interchangeable?
They are interchangeable. The MS flash is 1.75 inches wide, and the mold strip is 3 inches wide. Me personally, I prefer the mold strip because when you backfill, you may get that membrane being pulled down just a little bit as it gets backfilled, and you have a little bit more of a buffer when you use the wider strip. The other advantage too is you have 3 inches that could potentially be exposed to UV before you have to worry about the dimpled membrane. And no matter how well you compact the soil, you will get some settlement after the fact. This provides a little bit more leeway. That said, and the fine folks here at Source would be able to tell you, but there's probably a very negligible price difference between the two. So I would say always go with the mold strip.
That's great. And then if you want to just in the back of you, the MS mock-up you have behind you, I think that shows both examples of the MS over installation and then the installation over it, right?
Yeah.
If you want to just talk us through that, that'd be great.
Yeah, bear with me as I bring my camera over here. So what we've got here is two applications. I don't know if we can see that okay.
Yep, it looks great.
So this would be your traditional application. It's your Delta MS mechanically attached to your foundation, and you would use the mold strip at the top. You can put insulation directly over it. This is simply, I believe in this case, it's PL 300, which is foam safe insulation adhesive. So this kind of explains everything you need. Now, when you do foam over top, you do still need to protect it. And in this case, we've got a sheet of bent aluminum to protect it. On this side, when you do have continuous insulation, you want the dimple board on the exterior, we use the same foam, same insulation adhesive to hold it in place. And in this case, this is the screw fastener that holds the dimple membrane in place. And you can see, we've got 6 fasteners here. So this, I believe it's 1 for every 4 or 5 square feet. And that's how it's attached. And again, any water that does come down the wall, we want to flash it out and introduce the water to the outside of these membranes to keep behind here as dry as possible. This also keeps out any of the soil from getting behind the membrane when it's being backfilled.
Great mock-up. And then while you're over there, let's look at the other mock-up if you don't mind.
I should mention here, we've got the metal flashing. In this case, we've got the Delta flashing here in behind. This always comes down to sequencing. So in this case, this would flash down and over on a brick ledge. And then you've got your air barrier going over top. So you always have a water shedding application. The next application here is an example of our air barrier as well as our Delta Dry system. In this case, the Delta Dry and Lath. So this is your traditional stud cavity wall. Your insulation be here. Sheathing. We've got our Delta Vent SA in this case, along with mineral fiber insulation. Down at the bottom here, we've got your typical metal flashing as well as the multi-band. So in this case, because of sequencing, I decided to demonstrate the multi-band as opposed to flashing the air barrier directly over top. So
that's a great assembly.
Yeah. So if you look here, we've got the weep screed. And this allows any of the water that gets behind the this could be adhered stone or a stucco assembly. It's got holes in it to allow drainage. This allows water to drain out here, and it still provides an air gap between the insulation and the Delta Dry to drain out through the bug screen and out underneath. And so long as you have 3/8 of an inch, you have enough convective airflow to keep that assembly dry and be considered a ventilated cavity.
I can't tell you how much I love this assembly because it takes the risk out of EIFS and stone systems. It's such a well-designed, all the components match, they work together. It's great. I live personally in an EIFS house that's going to have to need a front facade replacement. And to me, this is the assembly and the system that I would use.
It really is a bulletproof system. So we did a ton of woofy modeling with the Oak Ridge's National Laboratory. We did hundreds and hundreds of assemblies, and every single one, it was off the charts from a performance perspective. There is no assembly that performed better that they've tested.
Yeah,
and, it was done by Achilles at Oak Ridge's National Laboratories, and I don't think there's anybody that knows Woofy better in North America than him.
He gives the trainings at the Air Barrier Conference on the Woofy trainings, and
Yes.
he's at summer camp, and he's the North American guru of Woofy.
Yes.
And Woofy is the tool that we use to analyze the risk in our assemblies. And I mean, if we had Woofy in the 70s, we probably wouldn't have had sick condo syndrome or failures of many EFIS systems. Or if we had your system, a lot of the reasons why those systems failed are figured out in that approach. So I'm excited to use it.
And that's just it. When it comes to buildings and what worked 40 years ago, 50 years ago, perfectly acceptable technologies then don't work now because modern codes require more insulation. And when you have more insulation, you have less heat loss, which is the point. But in having less heat going through the assembly, you have less drying capability. And building science is all about managing moisture and having more drying capacity than wetting potential. So you add insulation and you lose that drying capacity. So you have to manage water better.
Great. Thank you. The next question we have up is regarding the slides. The question is, would it be possible to get a copy of these slides to share with the audience and we can send as a follow-up?
Oh, yeah. Yeah, I can create a PDF and send it over to you and you can make it available. No problem.
Excellent.
Excellent.
Great. We'll do that on our end at Source 2050. Next question is from an existing Source customer sent through John. Can you walk us through how the Delta system can be used to prepare rough openings for a window installation? This is a good one.
Yeah. So applications vary. Sometimes
if you want to go back to your slides, your rough opening, that might be helpful.
Yeah, no, I can do that. Let me just go up and
I think the biggest innovation in your products there are those pre-engineered corners. They are wonderful to work with. I can tell you from an installer flashing air barrier nerd perspective that time is in the corners and there's a lot of risk in those corners. And I think you can explain your system, but it's a flexible, is it EPDM or what is the corner made of?
Yeah. Yeah, no, I do believe it's EPDM. So let me just go back to a slideshow here.
There you go.
Yeah. So this gives two examples. So sometimes, in commercial applications, you might get the windows detailed before the air barrier, or sometimes the air barrier goes on before the windows, and that affects how everything goes together. Typically, in a residential application, I would probably do your walls, fold your air barrier into the window openings, and then detail it accordingly, and then do your sill pan flashing with liquid flashing. Or if you are going to use a sheet sill, you prepare your corners first, and that way you don't need to detail any of the corners. And you work from the bottom up. And the whole idea is when you do so, you're shingling the material so that it's always a water shedding lap. The tapes are very, very good. We use a very high quality acrylic tape. So if you do have a reverse lap, it's not the end of the world. It's simply a matter of applying a strip of the multi-band tape. With our self-adhered membranes and tapes, all of them are pressure sensitive adhesive. So I need to stress that it's pressure sensitive. You really,
you need your hand rollers.
You need to roll these. And adhesion, if you stick it on and then try to peel it off and say, hey, this doesn't stick, well, you're right. And the reason why is it's a combination of pressure and time. And the technical term is dwell time. And your adhesion will actually improve over time, typically 24 to 48 hours. When we do all our lab testing, it is a 24-hour dwell time before the tape is tested. So temperature plays a factor in how well or how fast the adhesive grows legs and creates that bond. If you're in colder temperatures, it will take longer for that adhesive to set. So, I mean, our labs are typically in around the 70 Fahrenheit, 20 C range. So the colder you get, the longer that's going to be. You can overcome a lot of that by applying more pressure. but ultimately you really do need a combination of pressure and time. So as far as finishing the assembly, you can prefabricate your corners like this, wrap your sheet membrane over top. And then we also have the fluid applied application, and this is done after your air barrier is installed. It's important to note that this is a silicone, and the reason why we use silicone as opposed to some other technologies in the market is material compatibility. So a lot of STPEs and some products will create a hydroscopic condition with a product that's supposed to be hydrophilic, or make it hydrophilic when it's supposed to be hydrophobic. So it can take your air barrier that's supposed to prevent water from coming in and actually turn it into a wick and allow that moisture to come in. So in using silicone, we don't have that issue, but it's important that it's the right type of silicone. And in this case, it's a moisture cure silicone. You can't use an acid base. So always try to use the same manufacturer. And in this case, because it is a fluid, you can terminate it. There's no big deal with a reverse lap with this. The only downside to silicone is the only thing that really sticks to silicone is more silicone. So, keep that in mind if you have to put something over top of it, if you need to lap a sheet membrane over top, my advice is to apply more silicone and then set the sheet membrane in the wet silicone, let the wet silicone cure through that membrane. Otherwise, it is not going to stick.
Yeah, and that's one of the points of having a great technical department is you can make the phone call and find out what sealants actually work with the products in that application.
Yeah.
Great to see, and it's wonderful to see the full family of products and primer. Always check and see if you need primer. Some substrates need primer, some substrates don't need primer, but depending on your application, just read the technical documents and go through it.
I can tell you right now, all our third-party testing, we do our testing without primer, but please recognize that this is in a perfect lab environment. You will only get better results if you use primer, but we can't account for job site conditions. So how cold the substrate is, how well the product is rolled, how dusty the substrate is. And dust is probably the single biggest obstacle that we encounter. Well, wet substrates is probably the biggest, but short of that is dust. You have a really good high quality adhesive and it sticks to whatever you stick it to. If you stick it to dirt, you got a really great bond to that dirt, not to the substrate below it. When you use a primer, you encapsulate that dirt with adhesive and basically glue it to the substrate. And then when you put your air barrier over top, you are in fact adhering to a glue that's adhered to the substrate.
Yeah, I can't tell you how many projects I have witnessed that the primer was the main culprit of it not working, either being rushed or put on too thick or not put on at all or too much time in between. But primer is really the key to a lot of these components. But it's a part of your system, and it's nice to have options. So
with almost any building product, it's only as good as the install. And with many of these products, it's all about surface prep. If you don't have a good substrate, it doesn't matter how good your product is, it's not going to work.
And just from applauding you guys, the ABAA product certification is not an easy certification to achieve. It takes a lot of extra testing. You guys are available both in the US and the Canadian market with those testing and family of products. I applaud you on that end as well, because it's a full system test and all the components need to be tested as well. Last question, Shannon, you want to ask your question? Feel free, jump on.
Awesome. Yeah, great presentation, Michael. That was fantastic. I thought I knew almost everything you were going to show today, but I learned a little bit too. And I really appreciate you taking the time to share all of the lines with everybody on the call. So my question was around how you answered the first one, which was how are the composites attached to the exterior insulation? So you're using a foam friendly adhesive there. But
Yep.
what about the Delta facade for the open joint rain screen cladding? What's the perm rating of that? Is that similar to the other Delta Dry products?
So there's self-adhered and mechanically attached. So the self-adhered, because of the adhesive, is going to be lower and it's approximately 50 perms. The mechanically attached is over 150 perms.
Amazing. Great perm ratings on all of these. And I'm so excited you're getting your Declare labels this year.
Yeah. Declare we have, it's the EPDs that are taking time.
Oh,
It's
my
it's a
bad.
very
EPDs.
long, arduous task. It's I mean you're tracking carbon usage basically from extraction to the warehouse gate. So you think about all the suppliers, their supply chains, everything. It's a long task, and it's obviously done by a third party, and then the third party has it verified by another party as well. So, as quick as we can provide them the information, it still takes a long time for those reports to be generated, run through all their models, and then peer reviewed before they actually get published. So,
Absolutely. Yep. And thanks for joining us from the base camp. How are you being received there now that your doors are open?
So we only finished it in, I guess, the end of summer last year. It's still being developed. I'm still building more mock-ups. We actually have, if I turn my camera here, we've got a bunch of mock walls here that we use for training.
Very
Very cool.
nice.
And those mock walls can be used either as below grade or above grade. Detailing's pretty similar. It could either be a footer and a foundation wall, or it can be a brick ledge and a above grade wall. So window openings, how to detail it, all the products that go together. So yeah, we're bringing contractors in and providing training, and of course, showing them around, lovely. Niagara region as well.
Perfect.
Excellent.
Thank you.
Mhm.
Okay. Well, we're over the top of the hour, and I think that we could keep going, but we'd be mindful of everyone's time. Michael, this is a fantastic presentation. Thank you for taking
Thank
us
you.
inside base camp tonight. Thank you, Shannon and Kevin, as always. We recorded this presentation. We're gonna archive it. We're gonna make them all of our product workshop uh, sessions available on our website soon, and we will include a link to the slides as well, if someone had requested that. Um, I think it was really great to hear about the full system of that Delta offers, that it really has a solution throughout the building, that I wouldn't worry about kind of compatibility. And Source 2050, we're really happy to be able to offer all those products, all together, and get them out to you kind of in one order. So stop by Source 2050 if you're interested in pricing out any of these products. You can see there's a lot of expertise on this call to answer the questions that you might have. And thank you all for joining us. We'll be posting our next session coming up in a couple of weeks. We'll have some information shortly, and we will talk to you then. Thanks, everyone.
Thank you all.
Thank you.